All right, so in 3.5, we converted large numbers to scientific notation, and in our last regular lesson of this unit, we're going to convert small numbers to scientific notation. The rules are exactly the same, except you're making small numbers. So let's make sure we understand how to make small numbers. Right? 10 to the first is 10, so that is 1/10. And how do you write 1/10 as a decimal? I didn't add, you could have written that. It's point, right? That's 0.1, 1/10. Right? 10 squared is 100. So this is 1/100th, also known as 0.01. Okay. So 3 times 1/10 is 3/10, or 0.3, right? So this is 4 and 6 are what we're doing today. So guess what 3 times 10 to the negative first power is? Well, we just said that's the same as 1/10. So if that's same as number 3, it's also 0.3. Right? Because this and this are the same. And 3 times 100th, right? You know, if you want to, put 3 over 1, but either way, it's 3/100ths, which is 0.03. Well, if that's also 1/100th, then numbers 5 and 6 have the same answer, which is 3/100ths, or 0.03. Now we're going to learn, right? So if you could do that, you already can do tonight's homework, but there's a shortcut, all right? We were moving decimal points yesterday, or in the last lesson. Now we're going to be moving decimal points again, but they're going back the other way, right? Instead of making big numbers, we're going to be making small numbers. Right? So that's 19 billionths. And 19 billionths, right, is 1.9. Decimal is still going to go after the first digit, and it's still the number of moves. 1, 2, 3, 4, 5, 6, 7, 8. But if you do that, that's going to be 19, I think, 10 billion? 10 billions. We need, right, 1 billionth. All right, and so we need -8. Negative exponents make small numbers. Okay, so let's make sure we understand today. So we're going to evaluate the expression, and we'll express our answer as a fraction and decimal. I showed you this in the warm-up. Right, so 7 times 1/10, 7/10, also 0.7. Next. 7 times 100th, 7/100ths, also 0.07. 7 times 1,000ths, 7,000ths, also 0.007. All right, so here you can shorten these rules, right, because they're the same rules as last time. You have to take the decimal and put it behind the first digit that's not 0, right? So we're getting rid of the zeros in the front now. We're going to write 5.8 times 10. 1, 2, 3, 4 moves to get it there. But now you have to write -4 because that's what's going to make this number. That number there is 58 over 100,000, 58 hundred-thousandths, right? And that's going to be what makes it small. Okay. Let's try another one. Decimal behind the 6, get rid of those zeros. Then we have a trapped 0. The 6.07 that 0 has to stay. Can't get rid of it. Times 10, and we moved it 1, 2, 3. Times 10 to the -3rd. That's how you write that number, which is 607 100,000ths in scientific notation. So this is, right, 1, 2, 3, 4, 5 to get it there. So it's 4 times 10 to the -5th power. Right, this is 4 over, not 10, 100, or 1,000, or 10,000, over 100,000. That's what it is. Okay. So we use, right, these small numbers for things you see in a microscope, or even smaller. So the distance across a cell is that. Now notice, we don't write the commas on this side, and so it's sort of annoying. 1, 2, 3, 4, 5, 6 zeros there in front of the 5. So it'll be 5 times 10 It's not the number of zeros, 3, 4, 5, 6, but we got to get behind the 5, and 5 times 10 to the negative 7th meters, all right, is the distance across that cell. All right, so we're going to move the decimal back 3 times, right? It's the same rule as last lesson, but what am I doing wrong here? If I go that way, I'm going to make a big number. I'm going to make 2,600. When it's a negative exponent, right, that's making a fraction. I got to make it small. So I move it 3 times, but I add 2 zeros, and that is, I says in decimal form, so 0.0026. It is also 26 10,000ths, right? Tenths, hundredths, thousandths, 10,000ths. So again, same thing. You have to know there's a decimal point right there at 7. It's behind the 7, not in front of it. So 1, 2, 3, 4. We add 3 zeros because there's 3 empty spaces there, and it's 7 10,000ths. That's what that number is. But we're writing it as a decimal. Write the number as both a decimal and a fraction. Well, I just showed that. Move it twice, you get 0.047, which is 47 thousandths, right? 3 places over. 9, move it 1, 2, 3. We got 2 zeros, 0.009 or 9 thousandths. So notice both of those were thousandths, but this was to the negative second because it's where the number ends. Okay, so what was the rule about larger? The one with the bigger exponent is bigger. Still the rule. So what's bigger, negative 4 or negative 6? Right, well, there's 0. There's negative 4. There's negative 6. Right, this, oh, by the way, that's the symbol is greater than. So I can tell you that negative 2 is greater than negative 2 is greater than negative 5 because bigger is always in that direction. So that means negative 4 is bigger than negative 6. So this is the bigger number. Yeah. Now if you do the decimal point way, you could do the work. 1, 2, 3, 4. We get 3 zeros there. 1, 2, 3, 1, 7. That's 17 over 100,000. All right. That's a pretty small number, but we move this one 5 times and 6 times and get 5 zeros. 1, 2, 3, 4, 5. Right? That's 17, not out of 100,000. 1, 2, 3, 4, 5, 6. Right? That's a million over 10 million. Now, one of the things I like to do when I'm trying to decide what's bigger, let's think about this. If I'm shooting baskets and I shoot at a basket 100,000 times and I only make 17, you really stink, right? You make 17 out of 100,000. So that's a small amount you've made. But if you shoot 10 million times and only make 17, that's even worse, right? This is the bigger number, right? This is the bigger number. 17 out of 100,000 is bigger or better than 17 out of 10 million. Try this one. Right? This is 0.034. This one, move it 5 times, you get, I'm getting a little sloppy, move it 6 times, you get 5 zeros. 1, 2, 3, 4, 5. Right? This is way bigger. Negative 2 is way bigger than negative 6. Okay? Right? This is 34 out of 1,000, which is horrible if you shoot 34 out of 1,000 baskets. But this one is 9.5, that's a 9 there, sorry, is 95, right, out of not 10 or 100 or 1,000 or 10,000 or 100,000 or a million, out of 10 million again. I mean, it's pathetic. This is better. Okay, it's a standard that I tell you this. So some calculators, when they write scientific notation, you'll actually see some sort of 10 to the 4th. They usually cannot write, though, they usually can't write little numbers like that. So how do they deal with the fact that they can't write little numbers? Well, they write E. So let's rewrite this. If you ever see this on your calculator, and take any two numbers with lots of digits, you can take 2 really small numbers or 2 really big ones, And you'll see this, and this means 3.8 times 10 to the negative fourth. Okay, the e just means times 10 to what power? It's e for exponent. So what does this one mean if you see it on a calculator? 5.02 times 10 to the negative 6. If you have a calculator, a good one, you really should type in some really big or really small numbers and multiply them, because that'll cause so many zeros in the number that either it will say error or it will deal with it with scientific notation somehow. So are you going to do these before I put up the answers? Oops. Well, it was negative 3 here, but this is the biggest number by far. By far. And so negative 2 is the biggest number exponent there, so that is the biggest number. Do your homework.